Section 4.1 is factors and prime factorization. I can write the prime factorization of a number. Factors of a given number are whole numbers that are multiplied together to get the given number. Factors of a given number are also whole numbers that divide a given number evenly without a remainder. So we can use either of those ideas to figure out our factors. So in example 1, we're going to write 24 as the product of two whole numbers in all possible ways. Remember, whole numbers are numbers like 0, 1, 2, 3, 4. 0 is not a factor because 0 times anything gives us 0, so we can't get to 24. So let's try 1. Well, 1 times 24 gives me 24. So 1 and 24 are factors. 2 we can try. If you're not sure what 2 times something to get to 24 is, take 24 divided by 2 and we get 12. So since 2 times 12 equals 24, then 2 and 12 are also factors. We can check 3 next. 24 divided by 3 gives me 8. So 8 times 3 equals 24, which means 3 and 8 are factors of 24, numbers that we can multiply to get to 24. We can try 4. 24 divided by 4 is 6, so 4 times 6 gives me 24, which means 4 and 6 are factors. If we try 5, 24 divided by 5 gives me a decimal, so it is not a factor. And then we get to 6, but we've already used 6. We've tried every combination of numbers because we got back to numbers that we already had. And these are all the factors of 24. So 1, 2, 3, 4, 6, 8, 12, and 24 are all of our factors. Those are all the possible numbers that we can use to multiply to 24. So again, we started with 1. 24 divided by 1 is 24, so 1 times 24. 24 divided by 2 is 12, so 2 times 12 is 24. 24 divided by 3 is 8, 3 times 8. 24 divided by 4 is 6, 4 times 6. 5 gave us a decimal, and we already had 6. So this is, again, is all of our possibilities. Here we're going to write all the factors of the number. Number 1 is 30. So 30 divided by 1 is 30, which means 1 and 30 are factors, or things we can multiply to get to 30. 30 divided by 2 is 15, so 2 times 15 gives me 30. So 2 and 15 are factors. 30 divided by 3 gives me 10, so 3 and 10 are factors. 30 divided by 4 gives me a decimal. 4 doesn't work. 30 divided by 5 gives me 6. So 5 and 6 are factors. And now we have 6 already as one of our factors, which means we've tried everything. So my factors are 1, 2, 3, 5, 6, 10, 15, and 30. For 31, 31 divided by 1 is 31. Here's a little spoiler alert. 1 and the number are always going to be factors. 31 divided by 2 gives me a decimal. 31 divided by 3 gives me a decimal. 31 divided by 4 gives me a decimal. 31 divided by 5 gives me a decimal. 31 divided by 6 gives me a decimal. But my decimal there is 5 point something. So since we already did 5s, that's all the further we need to check. There are no other factors. So my only factors here are going to be 1 and 31. Try 3. 45. 45 divided by 1 is 45. So 1 and 45 are factors. 45 divided by 2 doesn't work. 45 divided by 3 gives me 15. So 3 and 15 are factors. 45 divided by 4, decimal. 45 divided by 5 gives me 9. So 5 and 9 are factors. 45 divided by 6, decimal. 45 divided by 7, decimal. 45 divided by 8, decimal. And we already have 9. So 1, 3, 5, 9, 15, and 45. Those are all of my factors of 45. Try 87. 87 divided by 1 is 87, so 1 and 87 are factors. 87 divided by 2 doesn't work. 87 divided by 3 is 29. If we look, 87 is odd, so it's not going to be divisible by 4, 6, 8, 10, 12, any even number. Because it's odd, it's not divisible by an even number. So let's try 5. I get a decimal. That doesn't work. Let's try 7. I get a decimal. That doesn't work. We already said 8 doesn't work. Let's try 9. That doesn't work. 10 doesn't work. When I divide by 11, I get 7 point something. So I get a number that we've already gone past, which means we don't need to keep going here. These are our only options. So 1, 3, 29, and 87 are our only factors of 87. A prime number is a whole number that is greater than 1 and has exactly 2 whole number factors, 1 and itself. A composite number is a whole number that is greater than 1 and has more than 2 whole number factors. Number 1 is neither prime nor composite because it only has one factor, 1. When we write a number as a product of prime numbers, we're writing its prime factorization. And we can use a diagram called the factor tree to write the prime factorization of a number. We keep splitting our number into factors until we get to primes at the end of our branches. And then the ends of all of our branches give us our prime factorization. In example 2, we're going to write the prime factorization of 630. If we look here, I'm going to start by making this little V. It's part of my tree. It splits 630 into 2 pieces. 630 ends with a 0, which means I know it's multiplied by 10. So 10 times 63 is how I get to 630. Guys, there's a bunch of different ways you could have split that up right away. It's even. We could have divided by 2. I just used 10 because I knew that one right off the top of my head because it ended in that 0. Now, 10 isn't prime. I can write that as 2 factors, 2 times 5. 63 isn't prime. I can write that as 7 times 9. Now, 2, I can't split up any further. It's prime. It's just 2 times 1. 5 is just 1 times 5. 7 is just 1 times 7. And 9 is 3 times 3. Now I'm going to try and break up those 3's here. 3 is just 3 times 1. 3 is 3 times 1. So this is the end of all of my branches. I circle my prime values, and that lets me know I can't go any further. So I'm going to write this in prime factorization. I have a 2 times my next smallest number, 3, times a 3, times a 5, times a 7. And the only other thing I'm going to do here, guys, is I'm going to simplify this just a little bit. 2 times 3 times 3 is 3 squared times 5 times 7. And that is my prime factorization. Feel free to pause here and give this a try if you'd like. We're going to tell whether the number is prime or composite. If it's composite, write its prime factorization. So if it has more than 2 factors, write its prime factorization. So 32 is even, which means we know that it is composite, because we know that every even number is 2 times something. So I can break this down to be 2 times 16. If you're not sure, take 32 divided by 2, you get 16. 2 is prime. It's just 1 times 2, so I'm going to circle it. 16, though, is not. It's 4 times 4, or 2 times 8, however you want to split that up. 4 is not prime. It's 2 times 2. Same thing here. 4 is not prime. It's 2 times 2. 2 is prime, just 1 times 2, and prime, and prime, and prime. So, to write my prime factorization here, I have a 2 times 2 times 2 times 2 times 2, which I can simplify to be 2 to the 1, 2, 3, 4, 5, 5th power. 56, again, is even, so we know that it is composite. I can take 2 times 28. If you're not sure, a more common one for 56, one of our math facts, is 7 times 8. That works too. Okay, and that's something that you'll find on your multiplication chart. So if you're ever not sure, break out your multiplication chart, look for the number on it, and use those factors, those things that multiply to get there, on your factor tree. 7 is prime, 1 times 7. 8 is not, 2 times 4. 2 is prime, 1 times 2. 4 is not, 2 times 2. 2 is prime, 2 times 2. So when I write my factor tree, I have a 2 times a 2 times a 2 times a 7. And I think it's helpful that I either cross them out or underline them or something as I go to make sure that I didn't forget any, especially when we're trying to put them in numerical order from smallest to biggest. Last thing I'm going to do here is simplify. So I have 2 to the 1, 2, 3, 3rd power times 7. 59. It's not even, so it's not divisible by 2. That doesn't add up to 3, so it's not divisible by 3. No odd numbers divisible by 4, 6, 8, 10, anything even. If we try it by 5, it doesn't work because it doesn't end in a 0 or 5. If we divide it by 7, we don't get a whole number. If we divide by 9, we don't get a whole number, and we get back to smaller numbers. So 59 is just going to be prime. There's no factors, no whole numbers that we can multiply there other than 1 in itself, that is going to give us 59. 83 divided by 1 is 83, which we know. It's odd, which means it's not going to be divisible by anything even, like 2, 4, 6, 8, 10, 12. Let's try 3, but if we look, in order for a number to be divisible by 3, its digits have to add to a multiple of 3. 8 plus 3 is 11. 3 doesn't work. In order for it to be divisible by 5, okay, they need to end in a 0 or a 5. This one doesn't. We can check 7. 83 divided by 7 gives me a decimal. In order for a number to be divisible by 9, our digits have to add up to a multiple of 9. That doesn't work. We can try 11. That doesn't work. And it gives us a smaller number. So here it's going to be prime because no other factors work. And here for 59 and for 83, I wrote out those divisibility rules and why they don't work. So those are the things I talked through for both 59 and 83 to show that they are prime. 101 is odd, so we know that it's not divisible by anything even. It's not divisible by 2, 4, 6, 8, or 10. We check 3. 1 plus 0 plus 1 gives me 2, and 2 is not divisible by 3. So 101 is not divisible by 3. 2 is also not divisible by 9, so it's not divisible by 9. It doesn't end in a 0 or a 5, so it's not divisible by 5. And when I divide by 7, I get a decimal, and 11 by a decimal. When I divide by 11, I get a number smaller than 11, which means it is prime. and I'll continue in a second video.